Thank you, Professor Mark. Ladies and gentlemen, as the guide between lunch or the barrier, I will try to make it clear and fast. Try to make everybody happy before lunch. I just give you a very simple, because you know, in comparison with the previous three speakers, Taiwanese scale is small compared to your size, but we are quite a large emitter for CO2 in the world. So let's take a look and see what happened here. And our challenge actually in Taiwan, we have 98% energy from outside. And in 2011, we have around 11.31 tons CO2 per capita. That's ranking 17th in global. And CO2 emission from fuel combustion was about around 250 million tons in 2012, around about 0.8% of the world capacity. And our government always make out the policy like energy efficient should be improved, and we need to provide stable energy supply, and we need to balance 3E, energy, environment, and economy, and always want to develop clean energy. All this is good for sustainable consideration. But three things you have to consider: cost, efficient, and the resource you have locally, and which is very complex right now in Taiwan. And in terms of reduction of CO2 emission, we have national target. I think most of the people in the conference know the target. It's been talking for quite some time, over 10 years. So I will just skip all the words here. And for our oil and gas, you can just read it, and it's very tough. In a very simple comment is that energy efficiency right now in Taiwan is a little bit easier to reach the target, but on the problem of CO2 emission is very difficult. Is my comment here. And this is our energy consumption pie chart. We just say if you look at the left-hand side, you know that most of the energy consumed is in the energy sector, which generate electricity for people to use. If you're doing differently by the right-hand side, you can see that industry consumes most of the energy, 48%, and transportation about 14%, commercial and residential combines around 26%, and energy sector for the power plant home use is around 11%. And let's take a look about the carbon storage potential in Taiwan. And I think our previous speaker is very clear, different. I mean, they reported all the large pilot scale program in the world. And I think the capture technology is purely R&D. It's quite, compared to storage side here, a storage program here is easier than storage program. And our storage capacity from our estimation, onshore we have around, for the oil and gas structure, it's around 2,800 million tons. And coastal and offshore, we have 9,000 to 68,000 million tons. It's all around the western coast, and which also all the power plant is. In one way it's good, and most of the power plant and industrial park are located on the western part, so suitable for some of the study and try to look at sedimentary basin or rock formation, etc. for the study. But this data here is from E3, and the Professor Lin has a talk in the afternoon. And some of the other information are different, and quite different actually. But that's, anyway, this is the data we use right now for our national program. And this real graph just gives you some of the activity, history, background of our CCS project, and ministry, EPA, or Bureau of Energy and the Ministry of Science and Technology. And all start around 2007, 2009, 2010. So you have different alliance or strategy alliance together aiming on the different emphasis. And I think this just gives you a reference for this. In our study, we think the general consideration for the CCS on research, development, and demonstration. We try to focus on two, I think everybody do the same thing. We try to focus on two emitters. One is power plant, the large emitter. The other one is industrial, like cement, iron, or other. And carbon storage, we're looking at gas reservoir here in Taiwan and deep saline aquifer. I think here technology integration is important. Doesn't matter which way you go, how to make it work, how to make it cost effective, and improve the energy penalty. This kind of things is critical. But we are now facing a little bit urgency in the policy and regulatory framework. Same thing happen always. We meet a lot of resistance from local residents right now for different projects. Even small projects, they have a lot of concern. But this is not really comparable to other countries because Taiwan is small. We have 23 million people living on an island of 36,000 kilometers square area. In that, on the island, we have 70% of high mountain. So the density of the people really making a lot of research projects right now is on hold. That's the critical part right now. Typically for storage. Technology development for the capture, technology and commercial scale demo and verification will be done before 2025 with solid solvent and chemical looping. For CO2 storage, pilot injection project, site categorization, storage capacity assessment, simulation, and or NMV or risk assessment. A lot of projects are undergoing right now. But the actual site for injection is not determined yet. Okay, this roadmap gives you a brief idea of what we did when we looked over like 10 years ago. And we try to make it clear that we have stepwise approach and try to make everything clear, scientific data is clear to everybody. On the capture side is running very smoothly according to the roadmap. Right now, again, for the storage injection program, we have kind of a little bit problem right now. So this just give you a broad idea of how we're going to do. And if you're talking about technology, ITRI is always used the so-called technology readiness scenario to evaluate all the technology which can be commercialization, which can be the research stage. And we make it like pilot stage, demonstration, commercialization, deployment. And in different technology level, you will have different projects. And according to this planning, you can see up to 2020, most of them are still in the pilot stage, demonstration stage. We are doing like a cost analysis or verification. We try to do small scale demonstration. And later on, I will give you some of the data we have in Taiwan, in not only ITRI, but Taipower, CPC, China Steel, they all have program here. this is very detailed between 4 different organizations which run in the CCS project right now. E3, of course, and Taiwan and CPC, and you can see they have different approach and different planning on the CCS. And in E3, we are doing most likely for the capture technology, and we're doing site characteristic, and we're doing MMB, we're doing risk assessment. We can help to do the site disclosure, long-term liability monitoring, but actually E3 currently is not going to drill any injection site. The actual work will lead to Taiwan or CPC running the storage project. And right now, in Taiwan is already drill 1 hole in Taichung dumping area, and CPC has a cooperative project with E3 doing the gas field EGR project. That's in Yongdersan. I will tell you later. And E3 doing the capture technology currently based on 2-3 different routes. For cement power plant, we use high temperature absorption with the calcium looping. Then in the industrial furnace, we use low temperature absorption and either MSP or NOF. And that scale is smaller in industrial furnace, like 3 kilowatt or up to 600 kilowatt. But with the calcium looping, you can up to 30 megawatt, and probably later on after we finish the 1.9 megawatt thermal project. And we hope in 2020 we can reach about 500 megawatt scale. And new combustion system, we were using the chemical looping study, oxide fuel combustion, coal, biomass gasification, those kind of things, and aiming to do the either using in hydrogen, CO2, or heat reusing to the power generation. And that's the E3 planning right now. And we have successfully set up a 1.9 megawatt thermal demonstration unit, an experimental unit in cement power plant with Taiwan Cement Company. The CO2 capture capacity is 1 ton per hour. And our CO2 removal efficiency right now is 85 to 90%. And we use rotary kiln with direct oxy-file design for calciner, flue gas recirculation for calcination, and also we capture the CO2 is the cost estimate to reach like $40 per ton. And we have several new patent pending application right now in this system. And I think our goal, the next target up to 30 megawatt, our cost target is around 25 to 30 US dollars per ton. And I just mentioned that anything will be considered as the cost effective and with the high efficiency to improve the energy penalty if you install the CCS unit. And for the storage technology development, I just mentioned we are most likely focused on the monitoring and simulation, site calculation, and those kind of things. We have not actually planning to drill anything from E3 site. And High Power, however, they have a very successful project in Zhangping industrial power. And they drilled around 3,000 meters. But after the local resident objection, right now this project is kind of on hold right now. So they are negotiating how to verify their process. So the actual injection is not beginning yet, but the site characteristic and study of the soil, those kind of things is already begin. And this is also his first one in Taiwan to do this. And We also have a project from Thai Power that they use CO2 utilization to like farming the algae and do the photobioreactor, those kind of things. And this from Thai Power Company. And the left one is in Ningpo power plant, and this one is in Nambu power plant. And CPC, their main focus is either EOR or EGR, which is reasonable for them. And the EGR phase 1 is doing together with ITRI. We have a small project in Yonghe-san, and all the study has been done, but the actual injection is not beginning yet. It's also with some of the communication and negotiation need to do with the local resident. It's the same thing. CPC, China Steel Company, has also has a project doing this, and this is actually Professor Tan's project. He worked with China Steel Company together to do the CCS project, and they use waste heat and water slag and process integration, including using the ammonia-based chemical to do this. And they also, after the capture of CO2, they also reuse it to farming the algae and try to aim the same thing, try to lower down the cost of the energy to use the CCS. And in the future, I think our approach is very similar to our previous speakers mentioned. That my personal view is either you do the technology by research, then demonstration, then deployment. The critical part still is the policy and regulation with the engagement of the public. How to persuade the local resident to agree or let them participate into your project is now critical to CCS. Probably capture technology, you can either develop it and you can use it outside Taiwan, but storage should be probably done within Taiwan. I think you will not send million tons of CO2 to other countries, which is not very feasible. And maybe other countries will not allow you to do that too. So CO2 storage is local problem. The local problem needs to be solved by local people. Everybody has to be involved. And this is difficult right now. We have a lot of experience to contact with residents of different local county, and everybody has different thinking and different information. And even the scientific data is not clear right now. So somehow we have to find out a general way or a typical way to communicate with others. Otherwise, it will be very, very difficult to continue to do the storage project here. And so I mentioned that policy is on the top priority. A lot of things have to be determined by the government, and regulation has to be explained by the government and accepted by the people. And collaboration with different associations, internationally or domestic, should be very, very focused. R&D for myself, I'm an engineer, I'm a researcher. R&D is easier if the target is set. R&D is difficult because they have to change quite a bit when you're doing different regulation. That's the point here. And communication, of course, right now is the critical point. How to let the public participation more involved and agreeable need a lot of Western people to join us. And how to communicate on what platform you can do, either website, conference, media, even direct discussion. These kind of things should be put in mind for everybody, especially from government. And I think that's it. Thank you very much.